That to-do list you have needs one more thing.
Hey everybody, happy Tuesday. Hope you're doing well. All right, I think we're good to go. Let me fire up PyCharm here. Maybe PyCharm, one of these. PyCharm, come on, there we go. All right, we are moving on now. We've finished 6 chapters in 6 weeks. You guys are doing great. This is about the halfway point of the class, right? Because we've got Thanksgiving break coming up, and okay, maybe not quite the halfway. One more week and then we're halfway through, right? We got 7 weeks there and then 7 more weeks of stuff. Oh, that's the wrong button there. Come on. Okay. So hopefully things went well in lab yesterday. I have a feeling that everyone is behind a week because labs aren't due until the week after, and it seems like people don't work on the lab that's assigned this week. They work on the lab that was assigned last week, and okay, sure, that's fine. It's your guys' practice, your guys' time. So as long as you're getting them done, that's good. We've got the second project coming up as well. That one is, where'd it go here? Oh, I'm zoomed way too far in here. Way too far in. Oh, it's not even in the coming up section here. Let me see if I can find it. Excuse me. Let's see. Maybe. Canvas always gets super slow when I want it to be working at a decent pace. Yeah, October 22nd, 3:30 p.m. So we got a week from Thursday. That one's going to be due, right? Let's take a look at this one. That's going to be our hangman game. Okay, so we'll talk about strings today, and this week we'll be doing strings. It may or may not be helpful for the hangman game. Right, this could all definitely be done with just like a list of characters. So you might find some shortcuts you like when we start talking about strings, but that's the assignment doesn't need them. Here's PyCharm. Hey, look at that. Come on, wake back up. I don't know why. Oh, it wants to update, that's why. Things just run slower, I think, with OBS. So last week we finished up talking a little bit more about functions. And we looked at some optional arguments, which are fun, and then how you might get a random word out of that word list for you guys. So let's do a new project. We'll start talking about strings. So that's chapter 7, strings. All right, come on, wake up there. All right, cool, we can get rid of all this stuff. So I'm taking a peek here at Zybooks. Again, looks like not a lot of participation is getting done still, but that's okay. Maybe most of you, half of you, are getting stuff done in Zybooks. Again, it is due at the end of the semester before you take the final exam. So I promise it does add up if you're not keeping up with it. Right? You don't want to leave that to the end where you have your final project to be due and this thing to be due all at the same time. So do invest a little bit of time in keeping up with the Zybooks there for sure. And again, you know, you can listen to me all you want, but you should do the reading and follow up with the textbook to help reinforce those topics, get those other little bits and pieces that they have there. Because I'm not talking about necessarily everything that comes out of the text. Trying to pull out the highlights, give you some examples there. So in the string chapter is actually relatively quick. There's a lot we can do with strings, but there's not a ton of content. And then on Thursday, my plan is to give you the sample midterm from last year, and then you know, I can ask questions, or I can answer questions. We can do a little review session there, and then next Tuesday when we do midterm review, is that what I had? Let me make sure I'm not making this all up here. Let's see. Let me double check again. Yeah, so we'll do the midterm review on Thursday, and then you'll have the midterm on 10/19. Again, it says in lab, we're just going to do it virtually. I'll open it up midnight Monday, and it'll be due by 11:59 p.m. You'll have to have it in, but it'll be timed, unlike the chapter quizzes. So once you hit start on that midterm, you will have 2 hours to hit the submit button, or an hour 45. I'll put it at 2 hours even instead of an hour 45. 2 hours to hit the submit button on it. So that way everybody gets the same amount of time to work on it, if that makes sense. Yeah, so we'll do strings today, and then at the end of today, I'll post the midterm from last time, and then on Thursday, I can go over the answers to it, and any other review questions you guys might have. Because if I don't give it to you till Thursday, it's just like anything else. Watching me solve the problems is not going to be very interesting and beneficial to you. You want to try them yourself, and then I'll give you the answers in case you had trouble and want to see, you know, how it compares to the way I approached it. So in this one, to ensure that no one wants to be collaborating with their neighbors and violating our academic integrity policy, I'll have a larger question bank. And hopefully then everybody gets a different set of questions to be answering to avoid encouraging you guys to work together, violate the academic integrity policy, and make tons of paperwork for me to fail you. Again, right, violating the policy, like cheating with someone else, is a immediate failure of the course, and you get reported to the dean's office, and then the dean gets to take care of it from there. And if I recall correctly, the university has a 3-strike policy where there's a university-wide list that's shared among all the colleges. So 3 violations of this policy, and you are no longer welcome to be a student here at U of M Dearborn. So we do take that very seriously. So and I'll do my part, make sure everyone gets different questions so that you're not even tempted to ask. Okay? We're all good there? I hope so. I think everyone took care of that module. I've got that academic integrity module out in Canvas that you guys could look at. And I think everyone took the quiz, which I think was assuming you finished the module from there. All right? Cool. So let's do some strings. So I think before we've looked at this alphabet string, and we said, you know, it's A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. I think that's the alphabet. Sure, uppercase, lowercase, don't matter one way or the other. And before we did that little exercise, it was like print out your name using that index notation, right? So I could say print alphabet of alpha bet at index 4 was going to be the E plus the alphabet at index, which one was that? I think that's like 9 maybe for the I. I don't know. I'll figure it out if it's wrong. Alphabet. Oh, no, R. I don't know how to spell my name. That was like 15, and then 9 I think was an I. And then alphabet index of 2 was a C. Right? And I think I get Eric back out of this. Let's give it a shot. This is not the kind of thing you should know, the index number of your letters. Oh, EP, I was close. P is, need 2 more, so 17. And then J is 1 too far, so 8. Okay, that looks right. Let's give that a shot. Awesome, now I get Eric. Right, so we can do that sort of thing. So that's getting stuff by index. The other cool thing we can do is use something called slice notation. And slice notation, we briefly mentioned it when we talked about passing a list. You could pass a copy. So we could say print alphabet. And we said if you put a colon here, you get a copy of the list. This colon here is actually the key to slice notation. So colon says I want to slice it. And what happens is the starting character goes over here, which is like 0, starting index, and the ending index goes over here, say 25. If you don't put them in, you get the beginning and the end, right? So that's optional start and end index. Default to beginning and end. So if you put nothing in here, you'll get the entire alphabet, and a slice gives you a copy of it, which is really cool. So that's how we were able to pass a list as a copy, so no one could modify it inside of our functions. What we could do, we could specify a start and end. So if I wanted ABC, I say give me everything from here up to but not including that number. So I'll get A, B, and C here. So the end is the one past. So the end index is one past, where it stops. Does that make sense? So like if I put in 3, I'm going to get 0, 1, and 2. If I just put in 2, I'm only going to get 0 and 1. So it stops is not inclusive. Maybe that's better. Is not inclusive. Right. So if we put in 26, it's going to stop at index 25, which is right. That's the one we want. But if you say, oh, okay, I know the last index is 25, and you put that in, you're going to drop your z here. Right. We lose the z because I told it to stop at index 25 and not include index 25. Okay. So that's the basics of slicing here. And now you can do some other fun stuff with slicing. In that, let's see, where is it here? You can give it a negative value. So -1 means 1 from the end. And because it's not inclusive here, we're going to slice off the z. So it'll stop at 1 less than the end. Right? That's the end, because there's no -0, right? So like -1 means, hey, it's going to go back 1, and then we don't include that one here. So the negatives are a little bit awkward, because it doesn't actually give you 25 minus 1, right? Because the last index is 25. It gives you, say, like the length 26 minus 1, right? So that's essentially the same as 25. So it's a negative is length minus the number. Length minus number. So 26 is the total length, minus 1 gives me 25. And if I put a 25 here, right, so I'll put that as the same here. It's the same as 25. Right, because we get the length minus 1 gives me the same thing here. So negatives are just shortcuts. You can use them if you want to say, hey, all but the last couple. Right, it's an option for you. Just a little shortcut there for some slicing. The other thing you can do, let's look at it, this one here. If we have numbers, again, this is a little bit awkward, but that's okay. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we could get a slice of numbers if we wanted. Sure. That one's not quite as helpful, but what's fun is you can do this thing called a stride. So we have numbers. So from beginning to end is optional, right? Optional beginning, optional end. And then if you put another colon, you give it the stride, which is how many numbers, or how many you go. So if I put in 2 here, it's going to give me every other. It could be the first one, and then the third one, and then the 5th one, or index 0, index 2, index 4, index 6, index 8. Right, so this should give me all the odd numbers. Nope, even, I'm sorry, even, because I started at the beginning. So this is evens. The 2 indicates it's selecting every other value. And you can stride by 3, 4, 5, whatever you want. You can pick any sort of stride that you want here. So I can get all the numbers that way. That's to get evens, sure. You can do something fun like that. And you can also do a negative stride. So if I have alphabet from beginning to end with a stride of -1, I'm going to get the alphabet backwards. So that's a quick way to reverse things. Just give you a negative strides on a slice. Now you can specify start and end here, but now what the start and end is, because we're going negative, it should be bigger to smaller. Right? If I say like, hey, I want A, B, C, D, E, so if I go from 0 to 5, it's really confused, because going from 0 to 5, well, if I start at 0 and go negative, I never get to 5. So you have to go backwards. You have to go from 5 to 0, And now I'm missing index 0, right? So actually I want 5 to the end. And when you go backwards, it's inclusive, which is really annoying because you get index 5. But hopefully that makes sense, because when you go forwards, it's inclusive. So the first position there is always inclusive. So if I start at index 0, I get index 0. So this saying start at index 5, I get index 5. Right? So if you put in 0, you're not getting 0, because the second position there, there's the start, there's the end. End is not inclusive. So it just takes a little bit of practice looking it up, seeing which way you want to do some slicing there. Okay? Let's say backwards slice. The start index, I should say, is inclusive. And you can do all of this exact same stuff with lists. We're showing you on strings because it's some common stuff people do with strings. Okay? There's some cool formatted strings you can look at. That's all fun. You guys can practice that yourself. With aligning characters and things, if you're printing stuff out, you could do that sort of thing. You've got options there. You can have fill characters, those are fun too. The floating point precision, we've done that. Right? We looked at how we would get so many digits with the print formatter, the colon 0.2f or something. I think we've done that. So like if you wanted to print, this is a formatted string, quote. It's a formatted string. This is pi approximate is 22/7, right? And then I put in a colon 0.2f to say, hey, that's my formatter. And actually, let's do a couple more digits. Let's go to like 5 digits out. Let's see how close we get to our pi approximate. Right, 3.14. Oh, it's kind of broken after that, isn't it? It should be 1.5, so it's not quite so close. So maybe within 3 digits. No, that's going to round up, isn't it? Yeah, it'll round up when we do it that way. So that's no good. So, but to 2 digits, that's a good approximate. 22/7, right? There we go. So that gets us close with that formatter here. So there's all sorts of formatting options. I'm never going to ask you to do it for any of our assignments. There's practice stuff you're going to do in strings that'll ask you to do some formatting just so you can get some familiarity with it. And if you need it, go look it up. It's nothing you ever need to memorize. Just know that Python's capable of doing that sort of formatting because it's really powerful. Okay. Other really cool things we could do with strings. Now, there's a ton of amazing stuff you can do with strings in Python, which is it's just a lot of fun. It's a nice, easy shortcuts for doing string manipulation. And a lot of times we do manipulate strings because we have to deal with text and do certain things with text. Did I spell that wrong? There, 2 P's in approximate. Thanks, PyCharm. So one of the fun things we can do, so if we have some sort of sentence here, I don't know, sentence equals, I don't know, what's a nice little example sentence here? How about the quick brown fox jumped over the lazy dog? And yeah, sure. So what I can do, if I want, I can replace things in sentence. So I call sentence.replace. And replace gives me 2 things. I need the old and I need the new. So say we no longer want this to be about a fox. So let's say let's replace fox with, what do you think? Felix. I don't know. That way we still have an F and an X in there. So I can replace the string here. So let's print sentence. Print sentence. We'll replace it, and then we'll print sentence again. Now let's see if we get Felix out. Oh, it didn't change it. Do you remember when we talked about strings being immutable? You can't change a string in place. So what this does is it gives you a new string. So we need to say my sentence equals sentence.replace. So it makes the new string in memory and then assigns it back onto sentence. So we're pointing at the new string in memory. The old one goes away, right? Now I can get quick brown Felix jumped over a lazy dog. Sure, that doesn't make a lot of sense, but that's okay. Now let's replace again. Let's replace dog with, what do we need? Something, how about a badger? Badger. That way we still get a D and a G in there, right? Okay. The quick brown Felix jumped over the lazy badger. And what you might see people do is they just chain these replaces on like that. So it's dot replace, dot replace. So the first one is replaced, and then as soon as that's done, we're going to replace again. People love doing it like that in one line. Just, saves one line of code, sure. And we still get the same result. Right, so you can call a function after you call a function after you call a function. Okay, that's fun. Now we can also use find. Find is really fun. So we can say, where is each letter? So we're going to say for letter in alphabet, we want to see where it is in the sentence, right? And really we want the lowercase letter in the alphabet, right? Or maybe we want the uppercase letter. I guess maybe it doesn't matter. So we want to say, where is it? So we're going to say the index of letter is equal to my sentence dot find, and we're going to find letter, is it 2 lower? I want to say 2 lower. Is that it? No. Letter dot lower. There we go. Letter dot lower. And we probably actually want to take sentence all lowercase here, right? Okay, so we want sentence to be lowercase to find lowercase letters in there, right? So let's make sentence equal sentence dot lower. So we'll lowercase the entire sentence, assign it back to itself, and then we can find each letter, and we're going to find the index of that letter. So then we're going to print a formatted string, f, then a string, so index of, and then the letter is the index of letter. So we should be able to find where each letter occurs in the sentence. And find will only find the first occurrence. So the first time that that letter is found. Uh-oh. Didn't find an S. Did I do something wrong? The quick brown fox. Am I missing? Where's the S in that sentence? I must be doing something wrong because that's supposed to work. Quick brown fox. Oh, jumps. There we go. Jumps, not jumped. There we go. Okay. My mistake. Jumps over the lazy dog. Okay, now we should find every letter. I was worried. So if it doesn't find it, as you saw, you get a -1. So if you get a find result back of negative, it's not found. Like T should be 0. The first index is T, right? We know that one's true. And then all the rest of them, right, should have a value here because we found that letter in our sentence. So we can use find. There's also a reverse find, rfind, searches from the end to the beginning in reverse. Find, you can also give it start at this location. So if you want to find how many times a given letter is in there, you can use find, but it turns out we also have an easy function there for count. So if we want to like how many vowels are in there, so let's have vowels equals A, E, I, O, and U, and we'll say for vowel in vowels, we're going to print a formatted string of, I don't know, count of vowel is sentence dot count vowel dot lower. Vowel dot lower. Let's count how many times each vowel shows up. So there's 2 A's, 5 E's, 2 I's, 2 O's, and 2 U's in there. So count will tell me how many times that letter, or even in, okay, so the other thing you can do, right, these don't have to be individual letters. You can count the word the if you wanted. So maybe we take a, I don't know, let's see if we can find Constitution, but for fun, Constitution of the U.S. And we just want the text. Text. Yeah, and maybe I can't spell it right. Let's find the right one here. Here's the text, ushistory.com. That looks legit. And that's a crazy we. Okay, sure. So let's copy this whole thing. Okay, sure. Okay, whatever. It doesn't need to be perfect. So this is Constitution equals, boom. Is that one string? Maybe. Nope. Let's back it up. Okay. Is that one string? Maybe? Uh-oh. We must have hit a... Where did we hit? Oh, there's an apostrophe in there. Okay, let's try double quoting it. Right? If it fails because of apostrophes, we should double quote. Double quote. Go to the end. Boop, boop. Double quote. Now it looks happy. Look at that. Look at that. It worked. One big, long, ugly string. I know that's terrible. I apologize. So that's fine. And now let's see, how many times common words come up. So do you want to throw me out some words in chat? What words should we count here? Like the and we and I don't know, anything you want that we can count, right? So we're going to have a words to count is, we're going to make a list here of words. And we should probably lower that, right? So let's say at the end of this dot lower, because otherwise we're running into trouble. Dot lower. Okay, so now we have a lowercase constitution. So throw me out some words in chat that we should count. I'll sit here awkwardly while you guys throw me out some words. United States, all right? So United States. 1, good, throw me some more. The, all right, I like it, I like it. What else? Should we do like in? Okay, in, we can do in. How about maybe people? Okay, that's a couple lists. So now what we'll say, let's see if we can figure that out. So we're going to say for word to count in words to count. Right, so I'll get one word at a time. I'm going to count it, so we're going to print f. And really, I can just do this, right? I'll just steal this one. Count of word to count in constitution.count word to count. And I already lowercased it, so I don't need any of that, right? So we'll just count it and see how many times we get those words. Oh no! Uh-oh, we broke it. What do we do? Invalid syntax. Uh-oh. Is it not? Dot lower? Alright, forget it. We just run that. Oh no! Oh, there's another bad string in here. Oh, there's an affirmation. Okay, so we need to escape that quote mark. My mistake. My mistake. Quote mark. I was not paying enough attention here. Okay. There we go. Okay. Now let's give it a try. And then we want to lowercase it again, right? So dot lower that. Dot lower. This is what happens. All right, let's run it. See if we get our count out. All right, so United States is mentioned 54 times. The word the is in there 518 times. In 294. People 2 times. I know there's 1, so there's only one other place there's people. People. 1, 2. There we go. Chosen every second year by the people. By the people. Should we check for like the word state? Let's do that one too. About state. About rights. Just for fun. We're just having some fun here. There we go. State 132 times. 0 times for rights. How about right? Am I doing it wrong? Should I do right? 1 time. Wow. So this must not include the Bill of Rights. Right, that's just the original Constitution then there, right? We can do the same vowel count. We can do any sorts of things. So this counting here is strings. It looks for strings inside of strings. It doesn't have to be character inside of a string. Just pointing that one out, okay? How's that feel so far? So in is super cool. We can also say if a string is in another string, do something. Again, similar to like, hey, if count is greater than 0, it's in. We could just ask if it's in. Right? So I could say if, excuse me, what do we want? If people is in the Constitution string. Constitution. Oh my goodness, I can't spell. Constitution. Print. We the people. Right? Oh my goodness. Constitution? I really can't spell. Right, so you can look for strings inside of another string here. And you can do a quick little if-else. So in here now, you're actually going to do a hangman example. They have a little hangman practice exercise, but it's not doing it in functions. Right, so the way that they do it here is not done broken out into functions like we're supposed to be doing, right? So for the assignment, the goal is to do everything inside of functions, to practice functions. So it's okay if you want to use that starter bit of code to make it work, right, to see what you're getting, but you're going to need to modify it to put it inside of functions, and that's really the exercise there anyway. That's what we're practicing is functions, not necessarily can we build out this hangman game. So you're welcome to use that to modeling your code, but you've got to do it inside of a function. Comparing strings, you can check greater than or less than, which is usually meaningless because remember we go back to that ASCII table. We say, hey, is this numeric value of that character less than or greater than or equal to the numeric value of another character? So it's going to do it letter by letter, case sensitive when you compare strings, and if you do greater than or less thans. So that's not always quite as fun. The ASCII table is kind of fun, but that's okay. Other fun things you can do, you can check if it's alphanumeric, if all the characters are alpha and number. You can check if it's a digit, if it's lowercase, if it's uppercase, if it's a space. You can check if a string starts with or ends with given characters. So like I think one of the examples, they do a little URL parser and they say, hey, if the URL starts with HTTPS, then it must be a secure connection. Oh, a dad joke. Okay, I got a good one. Let's see. I keep getting them sent from all my friends here because I know I always look for good dad jokes. Oh, here we go. So what do you call someone who tells dad jokes who's not actually a dad? They're a faux pas. Yeah, I'm bad enough I have to laugh at myself. I do it in person too. It's, you know, I'm used to being awkward, so. All right. You guys feeling good so far? Strings. Other fun things you can do. You can capitalize, which will actually just take the first character and capitalize it. You can lowercase it, you can uppercase it. There's a strip option, which will take out all the white space. So a lot of times when we do inputs, you might want to use strip because if they had any spaces at the beginning or end, it'll take all those out. You can even title case, which is fun. If you want every single word to be capitalized, there's a quick little title case. So there's lots of string exercises here in the text, which are really good. And then string splitting is probably the other most powerful thing we can do in Python. So string splitting will take a large string and break it up into chunks. And it's going to essentially give you a list back out, and it will split on whatever character you want it to. By default, it's a space. So if I have someone enter a long sentence, you know, I say input, enter a sentence, and I type something in. Oops, I should save that somewhere. So this is, I don't know, some value. Sure, some value is not great there, I'm sorry. And then I want to print some value dot split. Split is going to split it based on the spaces, any white space now initially. So when I run this guy, and we enter a sentence, and we say something like, hello there, I am the computer, you should obey me. We'll get it split out, and anywhere there's a space, it removes it. So we get each individual word now split out. So split is super powerful. We can do lots of really cool things with split, depending on what we'll call that as a delimiter. And you can change it. It doesn't have to be spaces. You could split on whatever you want. Right? It doesn't. You just give it a character and we'll split on that. So splitting is really cool. And then there's the opposite of splitting, which is joining. So join will take a list and smush them all together based on whatever character you want. So if I have a list of names, right, equals Eric and Bob and John and Susie. Susie, of course, with Z's, right? That's probably how you spell Susie. And Mary, sure. I can take that names and I can call it join, and I give it the character I want to join on. So I just want to space separate them, so I'll join with a space. It's going to take every item in that list and stick them together with a space to give me back a single string. Just give it some junk there. Oh, shoot. I am totally backwards here. Sorry, it is string join and then the list, names. String dot join and then the names. Yeah, this chapter is about strings, of course. There we go. Now we get that list space separated into one nice pretty string. And I can do any character I want. I could put, you know, a pipe Sometimes people like to pipe delimit things or comma delimited. Right, if we're going to put it in like a CSV file or a comma and a space, look at that. Comma and a space. And we get comma separated, and it's even smart enough not to put a comma after the last one. Right, trying to do this by hand, we might say like for name in names, create a result string and append in the name plus a comma and a space, right? It's so much easier than that. So this is the long, crappy way. We'd say, result is equal to a string, and for name in names, take result, and we'll append in there the name plus a comma and a space. Right, then we can print result. Right, we could do that, but now I still have that trailing comma at the end. So then, and a space, what I could do then is I would take result and I would slice it. I'd say result equals result sliced from beginning to -2 to take out those last two characters. Now you can see why join is so much nicer than this, right? Long crappy way to join. Boom, like one line. Occasionally it's awkward to follow, and it can be difficult to understand exactly what they're doing. So a lot of times you might just want to run it in debug mode, and you can check it out. Right? You can see the particular results. But it's a nice little shortcut to doing something like that. Okay, so we can use join. You can split and you can join again if you want to like change your separators. You can do some sort of funny stuff there. And that's actually, wow, that was fast. That is it for strings. There's a lot more you're doing in the text for practicing it. But in terms of showing you a couple things, what we're doing there, that's all the fun techniques here. So let me get you last semester's midterm here. Give me a second. I'm going to pop this off screen just so I don't pull up the wrong thing for a second. And I will go to last year's course. Fall, come on, show me fall. 2019. So I should be able to find things easier. That's okay. And quizzes. And midterm. Is that it? Preview. Okay, so here's last year's midterm. So first question's a freebie. You will enter your name, acknowledge you understand the academic integrity policy, and you understand what happens if you cheat. I've had to put this in because some people don't remember, and then they complain when I report them to the dean for cheating, even though it's in the syllabus. So it's a free point on your midterm just for doing that, okay? Then a couple of true-false style questions. If it's false, you have to correct the statement. Right, just like on the quizzes we've been doing. Some little short answer, like write the expression that prints yeet if first is less than second, or, I'm sorry, if less than or equal to second and third does not equal fourth, or fifth is 42. Some long-looking gibberish here, but like, can you write that relational expression using the logical operators? So first less than second, less than or equal to second, and third does not equal fourth, or fifth is 42. You'll print yeet. Okay? Variables should be what? Variable name should be what? Right, so some fill-in-the-blank style, some true-false questions. A lot of things you might have seen on your quizzes similar to that. So a bunch of short ones here for making up some of the points. Yeah, so this is write a loop header that I use if I want to loop through a list to be able to modify the items in the list. Remember, using a for loop, we can't do that sort of thing. You got to go by index. More true false. Okay, so now here's some of the longer ones. So those are all like 1 point each. Now we get to some longer questions. So 5 points for write a function sum of prime numbers in list given some list. That returns the sum of all items that are in the list that are prime. I even gave them the prime function, like is prime. Right? Anyone can Google that. Right? There's tons of Python is prime sort of things. This was an example of, hey, this is what it should do. Right? You're gonna write this function, and the numbers that are prime, right, 2, 3, and 5, I should get out 10 if I sum them all together. That's the sort of quick little question. It's not a project or anything, it's just write a function that does this. Write another one. Write a function bad hash that returns the integer sum of all characters' Unicode values. And then you'll write a function verify hash given a sentence and the hash to check. It returns true if the sentence has the same hash value as the hash to check given in the argument. So turn each character into Unicode in bad hash, sum them together. And then a verify hash gives me a true if the number that you gave it here is equal to what we got back here. Right, so 2 little functions there. Another one, write a function count vowels that counts the number of vowels in each sentence. Because y is sometimes a vowel. For every y you find, generate a random number between 1 and 10. If the number is odd, count that y as a vowel. just some, sometimes it's difficult to come up with silly questions that you cannot Google. And that's sort of my goal here. I have to come up with questions that you can't find the Google answer to, right? That makes sense? So sometimes you get some really weird stuff, but it's just, hey, write a little function that does this. Okay? So 1, 2, 3, is that it? 3? 3 short function questions, right? And some other true-false ones. It's not supposed to take long. I have been very bad in the past at writing exams that take way too long because I assume they won't take that long. So usually when I write an exam, I'll go through and I'll answer the question and I'll assume it's going to take 4 times as long as it takes me to do it. That's been a bad estimate sometimes, and occasionally that's because I wrote the questions. I mean, I don't use word or test bank questions because they irritate me, and I don't like how other people write questions. So it's not meant to be long. It's meant for you to be able to easily do it. Like the goal is for you guys for it to take an hour, and then I give you double the time on top of that. So let me print this off as a PDF. I will give this to you as a practice exam, and I'll upload this here to Canvas, and we can go from there. Save as PDF. Save. Maybe. All right, it's hanging right now, but I'll take care of that after. Any other questions? Let me commit this stuff to GitHub, and we can go from there. How you guys feeling? Do a little Twitch poll again? Let's do that. Let me do a new poll. Let me ask how you're feeling. Oops. Come on. Okay. How are you feeling? Oh, come on. Come on. Feeling. Bad, okay, good. Sure. So give me an option there while I go do that. Check out in Twitch chat. Tell me if you're feeling bad, good, or okay. And I'll commit this 1501 all 2020. There we go. Some strings. We'll commit and push. Commit and push. And let me know how you're feeling in chat there. Come on, let's go. All right, now it's pushed, so it should be out on the website. Again, the exam is open book, open notes, open internet, right? No good engineer, developer has everything in their head. I don't expect you guys to, so I expect you to be able to apply the tools and techniques that we've learned. So I'll give you questions, and you can use any of your resources to go solve them. That does not mean you can post on Chegg and wait for someone to answer it for you. All right, so let's see. 3 people are feeling good, 3 are okay. All right, that's a good place to be in. As long as no one's bad, feeling pretty good about that. All right, so I'll leave it at that. I'll be uploading that sample PDF in just a little bit once I can figure out why it's hanging there. And we can go from there. I'll be hanging out on Discord. If you have questions, let me know. If not, you guys have a great Tuesday afternoon. And I'll see you Thursday. We'll go over the midterm review, and we can go from there. All right, you guys have a good one.